So good afternoon, everyone. Hope you've had a great day at the summit, and thank you for joining my presentation. I'm Sharon, Shahrokhi, Tehrani, Product Manager of Machine Intelligence Retention Team at CBC. It's an honor to be here today and talk about overcoming black box model challenges, the evolving topic in the world of artificial intelligence. Before I start my presentation, I would like to show a little bit about my journey. I got my bachelor and master degrees in electrical engineering from Azad and Concordia universities. My first exposure to artificial intelligence was a neural network course during my bachelor. Then I got a chance to build a fault diagnosis system for autonomous underwater vehicles based on dynamic neural network and genetic algorithm for my master thesis. After graduating from my master, I decided that I want to enter the world of big data. So I got another postgraduate degree in big data and predictive modeling from TMU. I worked in industry in data engineer and data science role for a few years. Currently, I'm focusing in product leadership with focus on big data, ML, and AI. And my goal is to help businesses to gain value by leveraging the AI into their practices. And I'm training the future talents of data world as a data science instructor. For today, I've divided my presentation into four main parts, starting with defining the problem space that we are working in, the black box AI problem, following with the technical explainable AI solutions to address this problem. Then I'm going to share a case study from a CBC to see how we are addressing to this topic in my workplace. And for the finale, the main key takeaways. So without further ado, let's start the presentation. First of all, I'd like to give an overview of the problem space that we are working in, the black box AI problem. Let's start with the definition of the black box. So the black box models are developed from input data by algorithm, where we know what is the features that are entered to our model. So the input is known. We know the final decision, which is based on the outcome of the model. So far, everything sounds like we know everything, but the problem here is the process inside this box, which is unknown to us, and it's a question mark. To illustrate the problem, let's have a closer look to this network. As you can see, we have a network with lots of nodes, hidden layers. There is a connection between these nodes and hidden layers. There is a complexity to the functions and the joint relationship between the variables. So all of these factors makes it quite challenging for the data scientists and ML developers to come up with the explanation what's happening inside these algorithms. In other words, what's happening inside that black box. So we are facing a lack of explanation problem here. And this lack of explanation can result in ethical concerns, and it makes it difficult to trust the AI decisions. And these days, the AI functionality increases in our daily lives, so it can have a huge impact and serious impact in our daily lives. So some examples of AI role. So it can inform the police decision when it comes to criminal cases. There's so many facial recognition technologies used in that area. Or in the health industry, which is a sensitive area, it can inform the doctor decisions about diagnosis of disease or even recommending a treatment to a patient. Or even in the financial sector. So part of this summit is about finance. So it can inform the bank decision. So one very simple example, imagine that you are in the process of buying your first home. You're super excited about the process. You're waiting for the loan. And all of a sudden, you receive a call from the bank and they mention that you are disapproved. And when you're asking about the reasoning behind it, they mentioned, okay, this is based on an AI algorithm. There is no explanation for it. So imagine like how you're going to trust when there is no explanation of what's happening behind the scene. Now let's take a look to a real example. In 2019, Steve Wozniak, known as Woz, the co-founder of Apple Computer, accused Apple credit card for gender discrimination in their decision-making about the credit limits. Why? Because he got 10 times higher credit limits compared to his wife, although they were sharing the same assets. So this customer faced a discrimination-like challenge in the initial step because there was no explanation about decision and the criteria behind it. Although after the bank came up with some explanation about the criteria that leads to that decision, such as that it was only based on individual criteria like depth and credit scores. And they mentioned that the gender didn't play a role in their decision making. So again, in the first place, we see a discrimination. With the explanation, probably the customer feels slightly better about the what's happening behind the scenes and the criteria for that decision making. Now we have I think, good understanding about what is the problem here. So what is the solution? So the solution is called explainable AI, which is known as XAI. And I would like to start again with the simple definition of what does it mean. So explainable AI refers to generally a suite of methods and techniques that enables us to gain an understanding about how the AI and ML model works and why it drives the ultimate decision. Before I want to dive deeper and talk about these methods from a technical standpoint, I want to focus on our attention on the importance of explainable AI. So the first important factor is increased trust, transparency, and fairness. Trust meaning the level of confidence that we have in AI model and its final decision. And transparency meaning the level of detail provided about the model. And fairness, treating people fairly, considering all the sensitive attributes that can be included into the data that we have. And again, when it comes to the fairness, it can define based on individual level basis or group basis, depending on the problem that you're solving. So it's not only important about the model, but the data has such a huge impact as well, because the data collection and usage of it in AI world can result in ethical concerns, and it makes it sometimes difficult to trust the AI decisions. The more sensitive information that we are collecting, the higher probability of public mistrust of handling and collecting those data improperly. So with having a clear explanation, we can be able to address some of these issues and increase the trust, transparency, and fairness. The second point is avoid bias and discrimination. This is at some level connected to the first point. So in general, the AI algorithms are highly influenced by the training data. So, and the training data can include biases such as race, disability, sexual orientation, gender, biased historical human decision, or even social inequities. So if we are not even able to explain what's happening in the model, so we have a limited understanding about the possible biases and how they are formed inside the data. And that results in the bias and discrimination in our AI decision. And that makes it very difficult for the public to trust using the AI application for solving the problems and to trust that final decision. The third and fourth point is more from a technical standpoint, improving performance. So with having a good explanation, we are going to be able to find the parameters that contribute to the model performance and start to fine tune them. So it's going to give that capability to our technical folks. And again, control enhancement. With having an explanation, the data scientists and ML developers can find and identify the issues and problems into the system and start to find those abnormal behaviors and correct them. So at the end, all of these points, if we have them in place, can result in increased rate of adoption of AI among businesses. And that's something we are looking for. In this part of presentation, I would like to start and talk about more from a technical standpoint about these explainable AI methods. So the first way to divide these methodologies is based on the scope. So we can have local explanation methods and general explanation methods. In local, we are focusing on a single input instant at a time with utilizing the different data features. As an example, in the natural language processing, we have a text document and we want to know what is the sentiment behind that text. A local explanation in this example can be the feature attribution, the scores for each of the words in that text document. So we are focusing on one single instance, while in the general scope, we want to gain an understanding about the whole model. So we are focusing on array of input rather than one instance. In the upcoming slide, I selected some of the local and general explanation methods. So I cannot dive deep to any of them. I'm just gonna touch base them on the surface. I put the reference article in the appendix. Feel free to go through that and learn more about each of these methodologies. And there are a lot more research happening right now. So make sure that you are doing a search on those ones as well. So the first one that I selected called Shapley additive explanation. So the SHAP methodology is based on the cooperative game theory, which we have like in cooperative game theory, we have like bunch of players. They're kind of working towards the same profit. At the end of the game, we want to make sure that each of these players gain a portion of that profit, which is based on their contribution. So the same concept is going to be applied here. So we are going to calculate the SHAP values in order to find the impact of each of the feature inputs on our output prediction. So different methodologies can apply here for calculating that like values like kernel, linear, low order, and deep, and each of them like using different methods and techniques. The second algorithm from a local space that I picked for today is layer-wise relevance backpropagation, or LRP. So this technique is working based on the backpropagation to find the relevance score for each of the like backpropagating from the class scores towards our input layer. It can apply to our convolutional neural network and again, like recurrent neural networks. The way that it's being applied is slightly different. In CNNs, that's backpropagation happening from the output towards the input layer by layer, while in the RNN, we are doing it through the memory cells and the hidden states. The third algorithm in the local space, which is known as local interpretable model agnostic explanation, or LIME. So this one is working based on the perturbation methodology, meaning that we are generating a simulated data from our input space, and then we start to train a linear model based on that perturbated input space to see what is the predicted responses it look like. Two like examples I picked here. There are a lot more to explore in this area, but one is sound LIME, which the researchers use it to make predictions, to explain the predictions about a deep vocal detector. And in the K-LIME, they use it in order to gain an understanding about the Bayesian predictive models. Now I would like to look more into the general explanation methods. I picked 3 models here as well. The first one is called global surrogate models. So this methodology mainly used for highly nonlinear AI algorithm. So what's happening that they're trying to come up with a linear model or decision tree model in order to come up with an explanation about our first AI nonlinear model. So we are finding and extracting the embeddings from our neural network and then start to train a linear model on that. So when we have the linear model in place, then the coefficient of that linear model is going to help us to gain an understanding about our deep learning model. And one more point about this methodology, in order to understand those internal correlation, we can use the SHAP and LIME algorithm as well. Again, it depends like which methodology we want to select and proceed with. The other one is called concept activation vectors. These are mainly trying to learn about the internal state of the networks based on some human-friendly concepts. I picked 4 sub-techniques in this methodology as well, testing with concept activation vectors, which they are focusing on directional derivatives to evaluate the sensitivity of our output predictions on if there is a change happening in our input space. The other one is called automatic concept-based explanations, which is more trying to come up with visual concepts in order to help understand how the network is functioning. Causal concept effects, which is focusing on causal effects of presence or absence of some of those concepts on the output prediction of the deep learning models, and the concept SHAP, which focusing on defining the importance or completeness score for each of the discovered concepts. The last methodology in the general space that I select for today called a spectral relevance analysis, which in this methodology, we are creating relevance maps for the data space or data samples based on the LRP, and then we're doing the eigen-based cluster analysis on those relevance map in order to find the prediction strategy of our model. And then we have those in place with the cluster analysis. We want to identify what is the normal and abnormal behavior of our models. So these are the kind of division of the explainable AI methods from a scope. So you can look at it from a methodology perspective. I touched base it a little bit while I was explaining. So some of these algorithms can be based on the backpropagation, and some of them are based on the perturbation base. So in the backpropagation, we are using the backward flow of information from the output layer to the inputs to understand the influence and relevance of the inputs on the output predictions. While in the perturbation base, we are doing the random sampling or perturbated from our input space in order to find the impact of individual features to our output class. So here are some examples from each of these categories, like backpropagation and perturbation based. So feel free to refer back to these slides and learn more about each of these methodologies. So the other one, that there is another way to look into this explainability from the model usage. So some of the models are model intrinsic, meaning that they are inherently interpretable. But the point here is that the explanation here is only applied to this classifier, and you cannot apply to any network or any other architecture. While in the post hoc, the explanation adding the extra interpretability to our existing AI model, and that makes them model agnostic, meaning that they will work on any architecture and it can apply to any to come up with an explanation for any architecture and network. So here is some examples in that one. As you can see in the model intrinsic, we have tree-based and rule-based, which is kind of common. They are interpretable. And in the post hoc, we have LPR and SHAP, which we mentioned in the previous slide. More from a practical standpoint, so if you're using cloud in your work, so they are trying to provide the tools and functionalities in order to help with explainability. I picked Google Cloud as just as a sample. So they are in their Vertex AI, BigQuery ML, and other AI services. They try to come up with the functionality in order to help with debugging and improving the model performance and gaining a better understanding about how the model behaves. Another practical point is open source packages. So I know all of us working in the tech, so we probably know the GitHub. So it can be a home for explainable AI methodology. So they want, the objectives is to have a reliable, sustainable, and responsible AI. So they start to build some of those algorithms in the open source packages. So I picked 4 as an example here: Interpret, IML, Deep Explain, and Dr. Y. So as you can see, some of the methodologies that we covered in the local or global space, like SHAP, LIME, LRP, they will build. So you can start and put them in your practices and start using them for your projects when it's come to explainability. Now I would like to go through a case study from CVC, but I'm gonna look at it from a more practical standpoint rather than technical. And it's gonna be how we are addressing the, applying this AI and ML algorithm and adoption of it in different industries. So I'm from media, so I'm gonna look at it from that angle. But first, I would like to give an overview about CVC in general for you guys to have a better understanding. So our number one mission is to create a personal and relevant and engaging experience for Canadians. So, and to achieve this mission, one of the objectives is personalization, which we want to achieve it through data-driven automation and relevant recommendation based on the audience signals, explicit or implicit signals that we are receiving in our digital products. So one of the data-driven automations project that they select for today as a case studies are lineup optimization. So a little bit definition about the lineup to give you an understanding. So lineups are the pages on the website or the apps which contains a collection of the content. So in the past, the majority of these pages were curated manually by the content teams to deliver the content to the audiences. So the proposal here is let's semi-automate that. Part of it can be producer curated, and part of it is gonna come from a data-driven automation based on an AI and ML algorithm. So when we started this project, the hypothesis was this is gonna increase the engagement in both sections. In the producer part, because they're gonna have more time to highlight the contents for the audiences, so they can spend more time around like improving the contents or adding more features to it. And it's going to increase the higher level engagement in the automated part, because now that part is automated. There is more dynamic content is going to be delivered to the audiences. So it's going to result into higher engagement. So what was the problem? Again, the black box problem. Why? Because when we, again, start to propose this idea of, again, automation, it raised the question of like what's happening inside that automation phase. How we can trust the outcome, and is it aligned with the journalism practices or not? And all of them were valid questions, because we are about to change the workflow of some content teams. So they are not used to like look and or use any of the more automated process in their work. So how we are approaching it is more starting to work with them closely from beginning to the end of the projects. So meaning that they are bringing their like journalism expertise to the table. We bring our like ML and AI knowledge, and we start to partner and run the experiment together. So we have the involvement of content team, the A/B test team, plus the ML developers to make sure that we are having a fully collaboration from like end to end. And then we started with simple algorithms so that the non-technical folks can understand. And that helps us to build a foundation in order to run the experiments, see the outcome, and start to, again, evolve from there and building more, like using more sophisticated algorithm for our experimentation. The good news was that, again, like the project and experiment was successful. So we see the increase in the engagement with the content, both on the producer like sections and the automated section. And right now what's happening is that meanwhile that we are scaling some of those algorithms that has a positive outcome, we are running more experimentation and A/B testing with more ML algorithms to see what is the outcome is going to look like, and how we can scale those ones into the more pages and have more automated processes in place. Okay, now I want to just run through 3 main points for the presentation. So the first one is that explainable AI is still evolving. So the researchers and like organizations are working in order to improve these methodologies and try to embed them as part of their practices. The second important point is importance of the explainable AI. So explainable AI is now part of the technology. The AI is becoming a part of our technology ecosystem, our decision-making processes, and generating the insights. So it has a huge impact on our daily life. So we need to start to increase the trust, fairness, and transparency, and put the explainable AI into action. And the last point is development and selection of the methods. So the quality of the explanation methods is important as well, both from informativeness and effectiveness. So in order to have a consider that quality of the explanation, we need to have a very good understanding about the contextual of the problem that we are trying to solve, and then start to again, develop a model or like select a methodology that makes sense for the domain that we are trying to solve the problem based on our AI applications. And I'd like to bring the presentation to an end with this note that explainable AI is the future of the AI. And that brings us to the end of presentation. I'd like to thank you for your attention time. Feel free to connect with me on LinkedIn I'll be more than happy to exchange ideas and keep in touch with you. Thank you.